So now we've got two little switches. And again, there's on these switches, some of these leads are commoned together. So those are straight through. So on our circuit board you can see these are commoned through. So that must be that way around. Let me just double check again. It is, yeah. It's very easy to push that through and to stab yourself. Right, so we can solder these in. So now we move on to some more slightly delicate components. Generally you leave the delicate components that can be damaged by heat until a little bit later on, or as late on as you can. And this is the crystal. It doesn't matter which way around it goes, and that fits in perfect. So there, let me just spread those leads to hold it. Of course, you need to turn your soldering iron on. It doesn't work very well if you don't have it turned on. Just see and check that that is, I see that is lifted up slightly. So now, just reflow that and pressing it back in. That's better. That's why on components like this it's always easy and best just to check, has it soldered in okay? Has it moved after doing the first lead? Because if you solder multiple leads on, it gets difficult then to be able to adjust things. It looks like this diagram is saying this transistor goes this way around. Just bend that lead out a bit. So we'll do the same again with this. We shall solder one up and then just see how it looks. Yeah, it didn't move. Typical. But with transistors it's always good to let them cool down, especially if you're new to soldering and you're not so quick. You can end up staying a long time, putting a lot of heat into the device, and they don't always like that. Right, now we can move on to our capacitors. We've got a 100 microfarad and a 10 microfarad. Marked on the board. This one's marked for 10. And we have the positive side and the negative side. The negative is marked by the shading on the board, and there's actually a little plus sign on the other side just to indicate. If you were to solder these in the wrong way around, potentially, if you got a high enough current power supply, potentially these could explode. But at 5 volts it's probably unlikely, but it will do them damage if they're the wrong way around, and they won't function as they are required to. 100. And again with this one, it doesn't fit, it fits sort of snugly, but if the holes aren't perfectly aligned, don't try and force it, just leave a little bit of space. It doesn't have to be sat perfectly flush on the board. Excellent. We haven't got very many components left to go on to this. We have our buzzer. So the buzzer has a plus indication on the board, and on the sticker it says to remove the seal after washing. If you're going to wash your circuit board down, you leave that in place until you've done it. Now this is very poor. This does not fit at all. This is really poor. Obviously they've either changed the spec on this, or they just haven't drilled the board right for it. Let's solder one lead in. We can't get that down onto the circuit board, it will be causing too much stress on those leads. Although I'm tempted not to put it on at all. Half of these buzzers are far too loud, so it may get snipped off if it becomes annoying. Sometimes they decide to bleep for every single button press, and it just drives you crackers. So now we need to do a slightly bad practice thing of just bringing some solder to one of these joints just to hold it in place, so that we can solder the other one. Of course, Big Clive, he would just manage to use all of his 18 fingers on each hand to be able to hold the solder, the circuit board, and the component, and the soldering iron all in place while he solders it, but I'm not that good. There we go. Now we have our little display. The legend tells us which way up it goes on the silk screen. Let's hope it fits in. Not fitting in too easily. There's one pin that's ever so slightly not quite right. Try again. There we go. Just gently work your way around them and you're able to get that fitted. Again, we'll just tack one lead and just check that it's firmly seated down. Then we can tack another. So before we put that little circuit in, integrated circuit, we'll just do a couple of tests just to make sure that we haven't goofed up completely and that it's safe to put that in. First thing we can check is that there's no shorts on the power coming in, which there isn't, which is very good. Now, according to the schematic, there is diode protection coming in, so we can check that that is the case. We'll put our meter into diode. Positive coming in. Positive coming in the other side of that diode. And the other diode is for protection for the battery input, which we haven't got. So that's okay. That's just a couple of basic checks. Now the chip can go in. Again, it has a notch on it. And you see what's happening here. If I bring it up like this, may be able to see. Chip is just, the legs on the chip are just too wide. There are special forming tools you can use for this. You don't need them. You can just use a work surface and something flat like a pencil and just very gently bend those leads. Takes a little bit of trial and error just to get it right. Oops. Because sometimes that happens and you do it too hard. And then you have to bend them back out again. Strictly speaking, I should have on anti-static measures, a wrist strap, everything else, but they didn't bother putting any of parts of this in anti-static packaging. So I figure I can't do much worse than what has already occurred. So what we're going to use to power this is one of these little leads that come with the cheap Poundland USB power banks. And just nip off the end. Now helpfully they've made these red and black. Would you lay much money on those actually being positive and negative? I think we would be as wise to check, just to see. Red to red, and yeah, hey, it is 5 volts. Happy days. Move some of the debris out the way, and let's see if it powers up. Hey, look at that. There we go, counting up. So a nice little stopwatch. Be a handy thing if I decide to do any time lapses or anything like that. It's just a nice little simple circuit that you can make and solder up and be completed within a relatively short period of time. It's a lot quicker to do when you're not filming it. But there we go. We hope you enjoyed that project. Thank you for watching, and we'll see you next time.